Hello everyone, welcome to our pre-calculus lesson 2. In this lesson we will discuss finding the exact values of trigonometric expressions. Something like tan 45 equals to what, or tan 60 degree equals to what, cos 60 degree equals to what, this kind of thing. Okay, so these are our agenda. As you can see, review trigonometric function on the unit circle, because this is related to this topic as well, today's class as well. Finding the exact values of trigonometric function for 60 degree, and finding the exact values for the multiple of 60 degree. Uh, these two topics are interrelated, this second number and third number. Then some classwork, find the exact values of trig expressions, and then homeworks. So let's begin. This is a review. We already discussed this slide in our previous lesson, in the lesson 1. We are just giving this because they are interrelated. First of all, just to review, as you can see, the length of the side opposite to the adjacent to theta, what is the value? So this is the x is the adjacent side, this is the theta. If the theta is given, x is the adjacent side, you already know that. And this is the opposite side, and this point here, this x and this y, they actually represent a very significant thing when it is a unit circle. Unit circle means if the circle's radius is 1, that then it is called a unit circle. And we can use the sine, cosine, and tangent functions to define. Sine theta represents what here, cos theta represents what here. Okay, because we know the SOHCAHTOA formula rule. That rule we can use here to find out what this x represents, what this y represents, and we know that this x actually represents the cosine of theta, and this y represents the sine of theta, and tan theta means the sine theta divided by cos theta. That means we can just write y divided by x here. This x is the base, so basically cos theta is representing the base here, base of this triangle. Similar concept, we can actually talk about the reciprocal also. Cosec is the reciprocal of sine, so basically it is y, so it will be 1 by y. Sec theta is the reciprocal of cos theta, so this is x, this will be 1 by x, reciprocal. So they are the reciprocal of each other. And if we compare this figure, this circle with this one, they actually similar one. The first value will be cosec theta, and the second value will be the sine theta. This is just to show the connection. And now come here, where we are actually starting our today's lesson. This is the place where these things and these things are connected, as you can see. This is, if this angle is 60 degree, if this angle is 60 degree here, this line can rotate anywhere it likes. It can come here, or it can rotate all the way around. Okay, suppose the line is now at 60 degree. This line is at 60 degree. So at 60 degree, the point P represents, like, some two value will be here, since just like the ordered pair x value and y value. First value is x value is this. How this value comes, we will derive it in the next slide. We will find it out. How this value come here, how this value come here, we will find it out. So if the point is, if it represents this 1 by 2 and root 3 by 2, then this will be the cosec theta, and this will be the sine theta value here. And of course, this x square plus y square equals to, this will be 1, since it is a unit circle. And somehow this value and this value will act such a way so that by Pythagorean theorem we will always get 1 here. Okay, suppose if this value increases, then this value will decrease. Ultimately our answer will be 1 if we square them and add them. And ultimately our answer will be 1, since it is 90 degree. Pythagorean theorem says that. And also we already said that this line will be 1. The hypotenuse of this triangle will be 1. How do we know that? Because we said that we are discussing about the unit circle. That's why. Anyway, so let's see how that value comes, 1 by 2 and root 3 by 2, how it comes here. So you see, first of all, only one thing is given here. This is a circle. Let me try to draw a better circle. Although we have a circle here, let's try to draw a better circle. This is a circle, and say this is our center. From the center, this is the radius. Only one thing is given here, and that is the value of this radius is 1 unit. In other words, this is a unit circle. Only that thing is given. Now, if I draw another radius here, that will be also 1. Here also 1. The radius is always 1. Wherever it goes, it is always 1 because it is a circle. Because it is a circle. On the circle, it is 1. But I put this line such a way so that the angle here inside is 60 degree. The angle is 60 degrees. Suppose the value is here. I put it such a way so that the angle here is 60 degree. Angle here is 60 degree. Now let's draw a perpendicular from here to here. Let's draw a perpendicular from this point on the line. So our figure now looks like this. And only thing that we know is this value is 1. We do not know this value. We do not know this value. Now let's bring this figure here now, because we want to analyze. This is the exact same figure. This is 60, so this must be equals to 30 degree. As you know, this must be equals to 30 degree. Okay. So this is how this figure and this figure is connected. Now you see, this is 60, this is 30, and this is 90. Now if we can draw another 30 degree here, this will give us an interesting idea to continue our solution. What is that? Say if we draw another 30 degree here, which is drawn here, and then if we join it, then what is going on here? This is 30, this is also 30. So total is 60. Total is 60 degree. And then this is also 60 degree, this is also 60 degree, this is also 60 degree. Now all of them are 60 degree. How do we know that this is 60? Because if we draw here 30 degree, then the other angle will be 60 degree since it is 90. This corner it is 90. So what happened here? Technically what happened here? We know that this side is 1. Since all the angles are same, 60, 60, 60, that means their corresponding side will be now same. This is 1, so now this is also 1, and this entire thing is 1. Because this side is 1, this side is 1, this side is 1. Why? Because the angle is same. It is equilateral triangle. Now it is equilateral, same angle. All three angles here is same, so this is actually equilateral triangle. It will be, which equilateral triangle actually tells us that all three sides of the triangle is same, equal. Then it is equilateral triangle. And in equilateral triangle, by definition, all three angles also equal. In other words, we can say it, if all three angles are equal, then it will be equilateral triangle. So vice versa, we can actually say that. Now if this full line is 1, this is half, because this 30 degree makes it half. So this will be 1 by 2. This will be half. This is another half. Total is 1. This is half. This is another half. Okay. That's why we are saying that this is half. Now, if this side is half, this side is 1, what is the value of this one? We can actually find it out by Pythagorean theorem. Pythagorean theorem says hypotenuse square equals to this is square plus this is square. So let's find it out. So this is the Pythagorean theorem. 1 is square, or we can write it this side also. This is, let's give some name here. Let's give some, since it is b, suppose it is b. So b square plus half. We are considering this triangle. Half whole square equals to 1 square. We do not need that. So this is b square equals to this is 1 square means 1. I mean simple calculation. This is what I am sure you can do that. 1 by 2 whole square means 1 by 4. So from this side to this side, if it comes, so it will become minus 1 by 4. Then we can write it. We can do some LCM here, so it will be 4 into 1, so 4, then minus 1. 4 minus 1 equals to 3. That means 3 by 4. So that means from here we get 3 by 4. Now you see this side we have b squared. So b equals to what? So b equals to will be root of this. B equals to will be plus minus, of course, but minus we will not take. since it is length, so we will not have to take minus side. So this is root of 3 divided by 4. But we know that root of 4 means 2 and root of 3 we do not know exactly. Some decimal value we do not know. So b means root 3 by 2. That means now we know this side is root 3 by 2 and this side is half. Okay, so see, this is the value. This side is half and this side is root 3 by 2. This side is root 3 by 2. So you see, this is the length, this is the x value. So x value will come first. This is the height or the y value. You can see this is the y value. So for this point, coordinate is what? This side and then this side. So 1 by 2 comma root 3 by 2. This is how this 1 by 2 and root 3 by 2 comes. And in the similar way, we can actually do for, if it is 60 degree, we have done the calculation for the 60 degree. Similar way we can do for the calculation of 30 degree also. And 40 degree also, 45 degree also we can do the similar calculation. For 45 degree, this side and this side they will be equal. Okay. Anyway, so for 60 degree we are trying to develop everything now. And now we have found this value as the point here is 1 by 2 and root 3 by 2. So what does it mean? It means that now we know this value here will be cosine, or cos 60 degree will be equals to 1 by 2, and sine 60 degree will be equals to root 3 by 2. Let's write sine 60 degree. Let's write sine 60 degree here. Sine 60 degree here. I think you get it. And pi by 3 is written here. Pi by 3 means it is written in radian. Okay. Pi means 180 degree. 180 divided by 3 means 60. So basically, it is bringing us to the same position. It is bringing us to the same position. So this is how this circular thing actually gives us different values of the trigonometric functions. Okay, different values at different places. This is how we get it. All right, and another very interesting and important thing is, suppose here it is, what is the coordinate of this point? Think about this. What is the coordinate of this point? So this is 1, 0, right? 1, 0. And on the unit circle, what is the coordinate of this circle, of this point? This point coordinate is 0, 1. And what does it mean? How do we know that 0, 1? Because the circle is 1. So that's why we know that the height will be 1 here, because the height is the radius now. It means that the cosine, this is total 90 degree. This point is 90 degree. It means that cos 90 degree is equals to 0, sine 90 degree equals to 1. It means that sine 0 degree is 1, cosine 0 degree is 1, and sine 0 degree is 0. Sine 0 degree is 0, and cosine 0 degree is 1. So these values actually tells us some important information, gives us some important information they gives us. Okay. We have the extension of this in the next slide. So let's look. So now we can actually, we can tell sine pi by 3 equals to what? So pi by 3 means 60 degrees. So we can just simply say that extension is in the next slide. We have more. So sine pi by 3 means root 3 by 2. Cosine pi by 3 means this, and tan pi by 3 means sine value divided by cos value. So this divided by this. So this is how we get them. Okay. So let me show you the 10 part. This part will be sine 30 degree. This 60 degree divided by cos 60 degree. So sine 60 degree is root 3 by 2. So root 3 by 2 divided by cosine 60 degree equals to 1 by 2. But since this is, we can make it like one fraction like this, 3 by 2. 2 goes up, 1 comes down, so this and this cancel out. So ultimately we have root 3. Okay. So yeah, and we also, if you if you learn that table, then actually you know that tan 0 degree means 0, tan 30 degree means 1 by root 3, and then tan 45 degree means 1, tan 60 degree means root 3, tan 90 degree means undefined. So you see this and this, they are matching. This is what I want to say. So if you know more information about them, then actually that helps. Okay. This is the extension that I was referring here. This extension is a little bit important, and actually this is also, we can use this concept also for other cases. So this concept also, what does it mean? This is actually the same figure that you have seen, but the same figure is written in different places. So this is the 60 degree value, this is the 60 degree or pi by 3. Now you see, by using the reflection about the y-axis, you know, the reflection or symmetry, you know, the y symmetry. So by using the y symmetry, we can say that if there is a point here, we will have another symmetric point here. So see, symmetry we are using, and for that point, this value, only the x value will change. This will become minus and y value will remain as it is. So this point's reflection will go there, and this point's reflection will come here. This is the reflection about the x-axis. So basically this point and this point, both of the point will get the negative sign. And again, this point's reflection will go here, or you can consider it from this side also. Answer will come same. You will get it here. Okay. Now, what does it mean? It means that this is our sine or cosine or tan, whatever it is, 60 degree. But when we go to this place from here to here, then actually our angle increases. This is our 90 degree, then plus 30 degree increases here. If plus 30 degree increases, then it becomes 120 degree or 2 pi by 3. So if someone asks you now, what is the value of sine 120 degree? Then what will be the answer? Answer will be root 3 by 2. Or if someone asks you this way, sine 2 pi by 3 equals to what? Then your answer will be the same. Same question, cosine 2 pi by 3 will be minus 1 by 2. So this point actually here, actually helps us in many ways. Okay. Now see, what about this point? What kind of question we can ask about this? We can say that sine 4 pi by 3 equals to what? Sine 4, what is the value? What is the value of sine 4 pi divided by 3? Sine 4 pi divided by 3 is this value. And cosine 4 pi divided by 3 is this value. So 4 pi divided by 3, how can we do it in the calculator? In the calculator, you can do it in two ways. One is you can just write 4 into 180 divided by 3. 4 into 180 divided by 3, which is 240. And we can actually calculate it in another way also. If you practice it one more time, or 1-2 times or a couple of times, then you will get it that this is our 180 degree. This is the 180 degree line, and plus 180 plus 60. This is 60 degree here. Since this is 60, so this side also will be 60. So 180 plus 60 goes to 240. So sine 240, you see, this little thing here actually is giving you some sense about all of a sudden if someone asks, okay, 240 equals to what? Then you can actually tell the 240 equals to what. And all the angles you cannot say, but if the angle is multiple of pi by 3, then actually you can say this is pi by 3, this is 2 pi by 3, this is 4 pi by 3, this is 5 pi by 3. See, multiple of pi by 3. Pi by 3 is 60 degree. Multiple of 60 degree now you can say from this figure. Just suppose if you have this question, all of a sudden you can just draw a quick circle in your figure book. Then you can say, oh, my 60 degree is here, 60 degree value is this and this. Then you can go for reflection this side, then reflection downside, then reflection this side. So you can quickly draw this figure, and then you can actually tell the answer. And really this works. This sometimes works without the calculator. See, we haven't used the calculator like other than finding this value, which is also necessary. We can do it without the calculator also. So my point is actually without using the calculator, we can tell the answer. And this is what? This is how much here? You can see 5 pi divided by 3. 5 pi divided by 3. This line is 270 degree. This is 90. 90 plus 90 equals to 180. 180 plus 90 equals to 270. 270 plus 30 equals to 300 degree. That means sine 300 degree is minus root 3 by 2. Cos 300 degree equals to 1 by 2. Okay, and only you need this value to answer all the question. This is the elegance of this figure. Only you need to know this value. And also you see this value also you do not have to memorize, because it comes from where? It comes from our that just only simple calculation. Just only one was given, then we calculated this value. So that from that one, only that one, actually we calculated all this value, and logical progression actually gives us the other things. So this is how we can find out the exact values of 60 degree and multiple of 60 degree. And in the book, if you just see other calculations for 30 degree, multiple of 30 degree, for 40 degree, 45 degree, multiple of 45 degree, the situation is actually same. The process is actually same, and this works for them all as well. Okay, and this is actually fun. If you have time, just give some experimentation about all these things. Now let's try to solve some maths from here. Find the exact values of the trigonometric expressions. This is from the book. I have taken the book picture and some other pictures also. How do we evaluate them? How can we calculate them? Also, it is written, do not use the calculator. So let's not use the calculator much. I know I cannot see you, so I do not know whether you are using calculator or not, but still. So let's see what is going on here. Which method we can do? You can tell some other maths during the class. So these are easy maths actually. So okay, from the first line, let me do one math. 32 number. 32. Sine 30 degree minus cos 45 degree. So sine 30 degree actually. Sine 30 degree value is if you know that from our table that some standard values of the trigonometric functions, so trigonometric expressions, so you will know that sine 30 degree value is 1 by 2, and cos 45 degree value is 1 by root 2. Cos 45 degree value is 1 by root 2. So we just have put the value, okay, and then this, if we do LCM, it becomes 2 root 2, and there is some root 2 here, then minus root 2, so we have just only 2 here, like that. And if we want to cancel out this root 2 from the denominator, we can multiply numerator and denominator by root 2, then it will become, if you multiply both up and down by root 2 just to eliminate root 2 from here, then it becomes let's multiply that side. So multiply it by root 2, then root 2 here, also multiply a root 2 here, so ultimately it becomes root 2 into root 2 means 2, and this side we cannot multiply, so it will remain as it is. This will be 2 root 2, and this is 2 root 2 into root 2, that means root 2 into root 2 means 2, into 2 means 4. And you can see still we can take common from numerator, we can take 2 common, and from the denominator also we can take 2 common from here, since this is 4, so 2 into 2, and that 2 to cancel out, then it is, the remaining thing is 1 minus root 2 divided by 2. So this will be the solution, this will be the final answer. What we have done is we divided the entire thing by 2, both numerator and denominator we cancelled out by 2, or you can show it by taking the common and then cancelling it out, so that also you can do. What we have done here is basically just only one line, first line to this line, and the remaining thing is just algebra. We haven't done much there, and these are just algebra. Okay, let's try to do another math, one more math. 37 number. Let's do 38 number. 38 number, because 37 number also you can do if necessary. You have the answer. So this is sec 30 degree, cot 45 degree. Okay, sec 30 degree. We do not have to write it. So sec 30 degree value is what? We do not know. But we know that the sec theta and cos theta is reciprocal to each other. So we need to know that cos 30 degree equals to what? Cos 30 degree equals to what? So cos 30 degree equals to root 3 by 2 from that standard table, because these are standard value. 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. They are some standard value. They are some standard value. Cos 30 degree equals to root 3 by 2. So sec 30 degree will be opposite of this. The cos 30 degree is root 3 by 2. So it will be 2 by root 3. It will be 2 by root 3. Just reciprocal. Reciprocal. This is sec 30 degree. Sec 30 degree means reciprocal of cos 30 degree. So cos 30 degree is root 3 by 2. This will be 2 by root 3 into. Now it is cot 45 degree. Cot theta is reciprocal of tan theta. Okay. So we need to know tan 45 degree equals to what? So tan 45 degree equals to, is that 1? I think 1. Tan 45 degree equals to 1. So reciprocal of 1 is again 1. Reciprocal of this is also 1. Okay, I can check it. Yeah. So the answer will remain as 2 divided by root 3. So this will be the answer. Yeah, I think, yeah, tan 45 degree equals to okay, I can check it another way also. Yeah, this is 1, because 1 by root 2 divided by 1 by root 2 equals to 1. Yeah, that's correct. This is sine 45 degree, this is cos 45 degree. Sine 45 degree, cos 45 degree cancel out, so we get the tan 45 degree. Yeah, that's correct. So this is 1. Yeah, we need to memorize the list to give the quick answer, okay, or else it will take a little bit extra time. Let's solve one more math. Which one? Let's solve 43 or 44. 43 or 48, because there are some extra numbers with them. So, or yeah, during the class time you can tell me, like, if you want me to do some other maths also, you can tell. We can try them as well. There is also pi here, or this one. Both of them looks fine to me. Okay, let's try to do this one. More and more numbers here. So 2, then it is sec pi by 4. So sec pi by 4 means what? You know, this is sec, not a cosec. Sec means the opposite, reciprocal of cos. And pi by 4 means 45 degree. 45 degree, pi by 4. That means we need to know what is the 45 degree of cos. Okay, cos 45 degree, because the reciprocal of cos 45 degree will be the sec 45 degree. So cos 45 degree is 1 by root 2. This will be only root 2. That's why cos 45 degree is 1 by root 2. Then plus 4 cot pi by 3. So cot pi by 3 is the reciprocal of pi by 3. That means 180. Pi means 180. 180 divided by 3. That means 6. So 60. So cot 60. Cot 60 is the reciprocal of tan 60. So tan 60 equals to what? Tan 60 degree equals to 1 by root 3. Yeah, tan 60 degree equals to root 3. Cot 60 will be 1 by root 3. Cot 60 will be 1 by root 3. So now we can actually multiply them. This is 2 root 2. And this side actually we cannot do anything. So this will be 4 divided by root 3. If we want, we can now do some LCM. So it will be root 3. Then this side will be 2 root 3 into 2 root 2 into root 3. Then plus, this is just only 4. So this root 2 and root 3, it becomes root 6. We can write it. Does it works? I mean, it doesn't help. It doesn't help much, but just let's write it. 2 root 6 plus 4 divided by root 3. Yeah, but before we do that, actually we can to eliminate the numerator from the numerator, to eliminate root, we can multiply it by root 3, because that will be more helpful before we do that. That will be more helpful because there is a 3 here, so we can multiply it. So if we multiply both numerator and denominator by root 3, see what happens. This root 3 and root 3. So you see, this root 3 and this root 3 will become 3. Then 3 into 2 is 6. So ultimately it is 6 root 2. So ultimately this will become 6 root 2. 6 root 2. So ultimately this will become 6 root 2. 6 root 2 plus 4 root 3 divided by 3. Root 3 into root 3 means 3. Root 3 into, hey, why I'm saying this root 2 into root 2 means 2. Okay, root 2 into root 2 means 2, just only 2. Any number, if you want to, suppose 5 means root 5 into root 5. Why is so? Because there is half here, there is half here, so half plus half equals to 1. Power addition by the rule of exponent. Let's check the math once again. This is 2 sec 45 degrees. So pi by 4 means 45 degree. 45 degree means cos 45 degree means 1 by root 2. Yeah, 1 by root 2, 1 by root 2, 1 by root 2. So 1 by root 2, it will be 2 root 2. Then it is 4. Then cot pi by 3. Cot pi by 3 means 4 cot pi by 3. Cot pi by 3 means 60 degree. Yeah, this is 60. So 10 60 degree means root 3. 0 1 by root 3, 1 root 3. 1 root 3. So root 3. So it will become 1 by root 3, then 4 by root 3, 2 root 2. So this is root 3. Then if you do the LCM, 3 goes, root 3 goes there, 4. Then multiply both numerator and denominator just to make the denominator without the root, or rationalize the denominator. This is called rationalizing denominator. We are multiplying both up and down. Yeah, is this necessary? Sometimes the students ask, sir, is this necessary to multiply up and down by this to make that? In our Sullivan book, all the answers, if you see, this is 43 number also. In the Sullivan book, all the answers actually they write in terms of this kind of our ratios are not this downside. This downside is always rational, not irrational. Root 3 is an irrational number. So this math, now that I checked this math, they have written the answer. They have separated this one more line. 6 root 2 divided by 3. 6 root 2 divided by 3 plus 4 root 3 divided by 3. So this 3 and this 6 we can cancel out. So it will be 2 root 2 plus 4 root 3 divided by 3. Okay. So this is also one way to write the answer. So meaning that we can extend one more line. Here. We can extend one more line. But I think even in some cases, sometimes the students give the answer in this line also. That also sometimes we say that okay, she knows that how to find out this and that, but the smarter way is to go for the final calculation because it looks better. But you know what, this line and this line will give you the same answer. If you put it in the calculator, this line and this line will give you the same answer. Anyway, hopefully we will do more maths during our class. From here, you try to solve as much as possible, as many maths as possible from here. Let me explain one more thing here. Just one more thing before we finish. This is the last page of our slide. Just one more thing. Sometimes you may ask, sir, you was talking about all the degrees in between this and that. What about this pi? So what will be that pi value? So if I draw a rough figure, this is the value and this value is minus 1 comma 0. So you see that this is sec pi. Sec pi means our reciprocal of cos pi. Reciprocal of cos pi means 180 degree. So cos 180 degree means minus 1, because this is 180 degree, cos 180 degree is minus 1. So reciprocal means 1 by minus 1, that means minus 1 again, because 1 by minus 1 means minus 1. Okay, so from here, suppose you may ask, sir, what about sine 270 degree? How do I know that? This is a big value. Actually 270 degree is here in this point. This point value is 0 comma minus 1. So sine 270 degree is actually just simply minus 1. This is 1 comma 0, this is 1 comma 0, this is minus 1 comma 0, this is 0 comma 1, this is 0 comma minus 1. Okay, so this way actually we know some bigger value also. Suppose here 180 written, so 180 value is actually they are referring this value, and all the calculation is actually, see, we are referring with the unit circle. Very important concept of this chapter is unit circle. Always we will use it. Okay, always we will use it. The concept of unit circle, it will always help us. And during the class also you can ask, I can, if necessary, I can explain once again, no problem, about the concept of unit circle, since it is really important. Okay, you try to solve as many math as possible from here, from this list. This means actually, this means this all the math here, right? So we mean the same number. If possible, try to solve all of them. Okay, during the weekend, if you can, try to solve all of them. All right, so see you all. Thank you all. Thank you very much. See you all in the class. Bye bye.